Welcome back, mates. This is your favorite captain on board, Captain Jack. In the last lecture, we saw different layers in a PCB, and today we'll see how we can view or toggle these layers in Proteus. So, let's get started. First of all, I'd like to introduce you to my unique controller board, the Curiosity board. It's the teaser of one of the designs we are going to study under the microcontrollers. This board has almost all the layers that we need to understand. We may not go in the same sequence as we had in the theory lecture, but always the first things first, and we are going with. Oh, wait. Let's not get out of track, and let's start with the mechanical layer. So, the mechanical layer acts as the foundation of the PCB, just like the foundation of a house. In Proteus, it is denoted by yellow color and it is also known as the board edge. We can see over here in the bottom left, the yellow color represents the board edge. Then how could we make this mechanical layers? So these 2D graphics buttons are used for making the mechanical layers. So we have the line mode, the box mode, the circle mode, the arc mode, and a closed path, which can give any shape, any abstract shape that you want. Then these same buttons can be used for making of the keep out layer. That's the second layer that we had studied. This layer is denoted by the color. Instead of making that layer, I will just change this layer by right clicking on it, change layer, and keep out layer. So the keep out layer is denoted by the red color. This layer is necessary when the board is going to be covered by a container that will be covering a part of the PCB or similar restraints in the product. So to avoid overlapping of the parts on the circuit, we can make the keep out layer for the designer to understand that the components should be placed inside this layer. Then the important layer that is responsible for the electrical connectivity over which the tracks and the planes are laid is the copper layer. This layer is in the form of a foil that is placed even in between the layers of the board, which is FR4, so that the tracks and planes can be generated over there too. Over here we can see that the top copper is represented by something like a deep red color. Over here, after we select top copper, and over here this cursor is selected, so the top copper is denoted by something like deep red and the bottom copper is denoted by a deep blue color. So after I have selected the cursor, now when I hover my cursor over the circuit, almost everything is selected. So to avoid this, we have these options over here. We can use layer filter mode to select only the layer that has been marked. So I can move over the top copper and only top copper is highlighted. So to avoid the selection of the plane, I can select this one or deselect this one, and even when I hover my mouse over the plane, the top copper plane is not selected. Similarly, we can do with the components, we can do with the pins, tracks, we can do with the wires and so on. So after the top copper layer, the bottom copper layer, the most basic layers, we have other layers. As I have said, we can design 16 layer PCBs in Proteus. So over here in this option, in the display settings, we can change the display options, we can change the color that is used to represent. So here's the top copper, here's the bottom copper, and these 14 inner layers are used for the other inner copper layers. So I suggest to keep all the settings to be default and do not mess with them, and we can do the designing as per our needs. After the selection of the copper layers, we have the plane. So when we click on this planes option, we can select whichever plane we want, like the top plane or the bottom. Now you can see that both the planes are made of copper itself. So that's why the top copper and the top plane is of the same color, as well as the bottom copper and the bottom plane is of the same color. Now the topmost layer in a PCB is always the silk layer, which is used to denote the components or the various labels like I have named my board. So the name of my board is in the is the bottom silk layer. So we can see over here the bottom silk is denoted by pink and the top silk is denoted by a cyan color, which is the greenish blue tinge. So now if you observe, the top silk is not a mirrored image, it's directly like we can read it processor, but the bottom silk is has to be made a mirror image, because if it is at the bottom and we are seeing from the top, it obviously has to be a mirror image. So now we'll go to the 3D visualizer so that we can actually visualize these layers and some other layers that are remaining. So we can see the bottom silk layers. The curiosity board you can see is straight, and the naming of the components. So now the FR4 layer, which was not visible in the PCB layout, we can see over here in between this line, this represents the FR4 layer. And now the solder mask. Now typically the solder mask is of green color, but to understand better, what we do is we go into templates. In Proteus, the solder mask is shown by the resist option. So we'll make this resist completely transparent, and then we should be able to observe the copper beneath it. So usually, as I said, the solder mask or the resist is of green color. Apart from making the board attractive to impress whoever came to your mind first, the importance of this layer is that it provides isolation to the copper layers from the external environments. It stops any external noise from being included and also prevents short circuiting. So if we remove the solder mask, this is how our copper planes would be vulnerable to the external environment. So to avoid this, the resist layer has to be applied. So that's all about the various layers of a PCB. In the next video, we'll study about the selection criteria of the tracks in PCB. Till then, take care and miss your favorite captain, fellas.